In this video, we'll take a look at section 17.2, solving linear inequalities. The steps for solving linear inequalities are exactly the same as they were for solving equations, with the exception of the property where if you multiply or divide by a negative, then you have to reverse the inequality symbol. So the example I've got, and the step-by-step, is if we start with negative 3x plus 5 is less than or equal to negative 16, we want to isolate the x. Subtract 5 from each side. We end up with negative 3x is less than or equal to negative 21. Now we're going to divide both sides by negative 3 to isolate the x. This is, since we're dividing by a negative, we have to reverse the inequality. So we end up with x is greater than or equal to 7. So the solution, let me graph it, x is greater than or equal to 7. Means the solution to the inequality is an infinite number of solutions. Any number that's 7 or greater than 7, if you selected for x and put it in this inequality, let's say you selected x equals 8, then your statement would be true. So negative 3 times 8 is negative 24 plus 5, which is negative 19. Yes, that's less than or equal to negative 16. So a solution to an inequality is an infinite number of solutions. This is the graph, or we can write it as the inequality x greater than or equal to 7. So as we solve and look at, we've got 4 examples to look at. We're finding solutions to the inequalities. So first one, solve the following. 3 minus 2x is greater than or equal to 15. Again, same steps as you did in solving equations. We're going to subtract 3 from each side. We end up with negative 2x is greater than or equal to 12. Then we're going to divide both sides by negative 2. So right here is where we want to make sure that we're going to take this inequality and switch reverse directions. So we end up with x is less than or equal to 12 divided by negative 2, which is negative 6. All right, next example. We have 2x is less than or equal to 3 minus x. We want to get all of our variables on the same side. If we add x to both sides, we end up with 3x is less than or equal to 3. I don't have to worry about the rule this time because I'm dividing by a positive number. X is less than or equal to 1. All right, next example. Same type linear inequality, just a little bit more complicated because we have fractions. I wanted to remind you, if you want to get rid of fractions in an expression, take a look at all the fractions. You've got a denominator of 2 here and 4 here. If you multiply the entire equation by the common denominator, 4 in this case is our common denominator, it will eliminate all of your fractions. So if we take 4 times 3 halves, this isn't true just for inequalities, this is for any sort of equation. We get 2 times 3 is 6 times 1 minus x is greater than 1/4 times 4 is 1 minus 4x. So the first step wasn't solving an inequality, it was getting rid of our fractions so we don't have such a complicated equation. Now follow steps for solving. We get 6 minus 6x is greater than 1 minus 4x. I'm going to, let's see, add 4x to both sides. We get 6 minus 2x is greater than 1. Subtract 6 from each side. Negative 2x is greater than 1 minus 6 is negative 5. Now we're dividing both sides by negative 2. So our inequality has to switch direction. X is less than a positive 5 halves. All right, last example is solving an inequality that has 3 members. You can think about this in a couple of different ways. You can keep it as is and solve for x in the middle by doing, in this case you would subtract 3 to all parts. Or you can rewrite this as 2 inequalities. and solve each one of them separately and then put them back together at the end. Okay, so if we solve it as a single, keep it as one single expression, subtract 3, but we're going to subtract 3 to each component. So we get negative 4 is less than 2x is less than 6 minus 3 is 3. To get x by itself, we divide by 2. We divide every part by 2. We get negative 2 is less than x is less than 3 halves. Okay? If you were to separate, you would do the same steps. You would still subtract 3. We'd get negative 4 is less than 2x, divide by 2. Then we would get same here, subtract 3 from both sides first, divide by 2. Then you could put them back together at the end.